All right. This is a screencast walking you through Module 5, Lesson 4 about direct variation. And already I'm going to give you a spoiler alert. Direct variation is the same thing as a proportional linear relationship, or just a proportional relationship, okay? Okay, let's get right into a couple of examples. It says a recipe for tomato soup calls for 1 cup of tomatoes to make 3 servings. In this relationship, the number of tomatoes varies directly with the number of servings. I don't know why there's not an S there, but anyway. Okay, again, direct variation is also known as a proportional relationship. Here's the key, guys. If you plot out these points, it will make a straight line on a graph. But you also should keep in mind that if it's a direct variation or a proportional relationship, this line will go through the origin, 0, 0, okay? And I can kind of reason that out if I look at this particular table. 4 cups makes 12 servings, 3 cups makes 9 servings, 2 cups makes 6 servings, 1 cup makes 3 servings. If I had 0 cups, that would make 0 servings. So the point 0, 0 makes sense to go with the rest of this, and this line would go through the origin. So this is a direct variation. Okay. All right, I'm now on page 232. A direct variation is a special type of linear relationship that can be written in the form of y equals kx, where k is a non-zero constant called the constant of variation. Okay, it looks so different and everything, but really it's not. Okay? Okay, haha. Tell whether each equation represents a direct variation. If so, identify the constant of variation. Okay, so that's what we're about to do. But here's what I want you to know. For whatever reason, they're calling it K, but you have been familiar with it as M, because M and K, really, they're both the same thing. It's slope. So they're using K for a direct variation. You know, why, I couldn't tell you. But just understand that that's really your slope. Okay, so could I have said y equals mx? Sure. And then you start wondering, well, what about y equals mx plus b? Well, y equals slope times x, y equals mx plus b. Well, b is 0 if it's a direct variation, because remember, it's running through the origin. And so y equals kx, y equals mx plus 0, that's all the same thing. Okay? All right, let's look at this first example. Y equals 6x. Equation represents a direct variation because it's in the form of y equals kx. In other words, y equals mx plus b, where b is 0, so it's running through the origin. Okay. Look at example B. First of all, let's solve the equation for y so that it's in that slope-intercept form, or it's in that y equals kx form. Okay. And I didn't fill in all the lovely, cute little boxes, but if I solve for y, I'm going to do that by, first of all, I moved the positive 7y over, and then once I got the y term isolated on the other side, I divided both sides by negative 7. Okay, so negative 2x divided by negative 7, and you get y is equal to 2/7 x. And then if you're thinking, well, where's the y-intercept? Well, the y-intercept, you can put like plus 0, but you don't need to, okay? This equation does represent a direct variation because it can be written as y equals kx, which we just did, and the constant of variation, in other words, the slope, constant of variation is 2/7. Okay, I want you to notice something. If I take this and write it in standard form, in other words, I would have to have ax plus by, and remember when oops, that's plus a negative. To do that, I'd have to move that y over. 6x minus 1y, well, I've moved everything. So if I put it in standard form, here it is. 6x minus y equals 0. Down here, negative 2x plus 7y equals 0. Here's the key. If you write an equation in standard form and c is 0, then the equation written in standard form is direct variation, okay? C's got to be 0. If c isn't 0, then you're going to have a y-intercept of something other than 0, and it's not direct variation. It's still a linear equation, but it's just not going to run through the origin, so it's not direct variation. Okay, so here, 4x plus y equals 9. C is not equal to 0 because c is 9. I know it's not direct variation. If I solve the equation for y, like y equals mx plus b, I get negative 4 for my slope, and I get a positive 9 for my y-intercept. So this line does not go through the origin, so it's not direct variation. All right, over here, if I take, well, let's see, this I'm solving for y, but let's put it in standard form. If I wanted to move the y over, I would have 3x plus y equals 0 if I wrote it in standard form. Okay. Again, standard form, I have c equals 0. When I rearrange it to solve for y, I just get negative 3x plus nothing, so it's going to run through the origin. Yes, this one's direct variation. Constant of variation is negative 3. If I asked, what's the slope of this line? You say negative 3, because the constant of variation is basically your slope, just in disguise. They're calling it by a different letter for whatever reason. All right, on the bottom of page 233, I didn't work either of these problems, but I just used the area to write like a little reminder. So if this is your equation of your line in slope-intercept form, remember m is slope, b is your y-intercept. If your y-intercept is 0, then your equation becomes this. And if we call slope k instead of m, then your line becomes this, and that is your direct variation equation that they gave you at the top of page 232. So just keep all of that in mind, that k and m are really the same thing, and we just call it k when we're talking about direct variation with a line that runs through the origin. Okay? All right, I'm now at the top of page 234. And example 3 says to write a direct variation equation to model the situation and then solve it to answer the question. So 2 yards of fabric costs $15. And ultimately, they want you to find the cost for 7 yards of fabric if the cost of the fabric varies directly with the number of yards. I'm already thinking proportional relationship. Before I even do all of this, which we're going to do, I can do this. 2 yards is $15. So 7 yards is, I don't know, but I've just set up a proportion, and you guys already know how to do that. 7 times 15 is 105 last time I checked. Okay, so cross multiply and then divide by 2, and that gives me $52.50. Okay, so 7 yards of fabric, it's going to cost $52.50. Let's make sure that we get that with this way of doing it. It's just another way to work the problem. 2 yards of fabric costs $15. The cost varies directly with the number of yards you're purchasing. Okay. So it says write the equation for direct variation and solve the substitute the values of y and x from the known information. Sorry, I can't read today, and solve for k. All right. So 2 yards costs $15. All right. So the 15 goes over here where the y is, and the 2 goes right there. So that's 15 equals 2k, or k2, but 2k makes more sense to me. Divide both sides by 2. And 15 divided by 2 is 7.5. So the equation is y equals 7.5x. And if you think about it, yeah, it should go through the origin. If I buy 0 yards of fabric, I'm spending $0. So, I don't have a y-intercept other than the fact that it's 0 because it's going through the origin. So when x is 7 yards, then that's going to be 7.5 times 7. And let's go over here and do some old-fashioned math. 7 times 5 is 35. Put down the 5, carry the 3. 7 times 7 is 49. Plus 3 is 52. Put in your decimal. Right, and I get the same thing as when I set up my proportion. Because remember, back here a couple of pages ago, we said direct variation and proportional relationships are all the same thing. Okay, so each yard of fabric costs $7.50. That's my constant of variation, or my slope. So 7 yards of fabric would cost $52.50. Okay, let's look at number 7. The cost of 5 pounds of apples is $12.45. What will be the cost of 12 pounds of apples if the cost varies directly with the number of pounds purchased? Okay, so first of all, I'm hoping that you recognize that the number of pounds of apples is going to be your independent variable, because it's the number of pounds of apples that is going to determine your total cost. So pounds of apples is independent, cost is dependent. When you have 5 pounds of apples, it is going to cost you $12.45. Then what we're going to do is we're going to take that y equals kx, and we're going to put this in where the x is, and we're going to put this in where the y is. Okay, then I'm going to divide both sides by 5 to solve for k. And I'm going to use this space over here. I'm not going to work 8, but I'm going to use that space. All right, assuming my math is correct, when I take $12.45 and divide it by 5, I get $2.49, which is going to be my K, the cost of apples per pound. All right, so now I'm going to try to squeeze the finalized formula down here. Okay, so in the form of y equals kx, here is your formula. And K is $2.49, so it's $2.49 per pound to get your cost. Now, because this is direct variation, in other words, it's a proportional relationship, frankly, you could have set up a proportion also, and you would have wound up with the same answer, okay? So I'm not going to actually solve it, but if 5 pounds cost you $12.45, you could ask yourself the question, well, what does 1 pound cost me? Question mark. And then you just cross multiply and solve for the question mark, the n or x or whatever. Okay, so I'm going to wind up just using this one screencast because I think we are good as far as direct variation. I'm just going to remind you of a few things, okay? So, direct variation is otherwise known as a proportional relationship. So, if you have $12.45 is 5 pounds and you want to know what's the cost per pound, you can set up a proportion because direct variation is proportional, okay? It follows this format, y equals kx. K is really slope in disguise. We're calling it K for some reason and not whatever, okay? And the other thing is it's going to run through the origin.